So hello everyone, welcome to meetup 48 of DevOps Porto. We want to welcome you all to our new edition, our first edition of 2022. So as you already know, we are a community that aims at building bridges between development, operations, communities, companies, people in general. You can find us at the usual locations, our website, our Twitter, our Slack channel, and you can reach us by email. So these are just some general guidelines. We've been using Zoom and the like for the last 2 years, so I'm pretty sure you're mostly used to it by now, but just some general guidelines for us to make this a welcoming place. And after the presentation, as usual, we'll have a small Q&A, so you can write your questions in the chat and we can make them to our speaker, or you can just raise your hand and ask the question yourself. Please follow us on, go to our Slack channel to keep the conversation going. And today we're going to have a talk delivered by Marco Amador, who is a chapter lead for data engineering and SRE at Anova. Marco is one of my fellow co-workers, so thank you, Marco, for being here and delivering this talk. And this talk is going to be entitled GitOps and Progressive Delivery, where Marco was going to show us a little bit about the work that is being done at Anova. So Marco, the floor is yours. You can take us ahead.
Okay, thank you. Let me please share the screen. Okay. Thank you, Ricardo, for having me here. So let's start. Okay, so I plan to talk a little bit about the cloud native journey that Anova has been doing over the last 2 years. And then if everyone is okay with that, I think I could do a little demonstration about how we are doing progressive delivery, a little hands-on example. So Anova, not sure if all of you know the company. It's not a very old company. It's a kind of recent company, but it's the resulting of multiple mergers of a very more experienced companies. And the resulting of those mergers was Anova, which is from the start leading global provider in industrial Internet of Things, more specifically on remote telemetry, or as we like to say, helps our customers in their logistics optimization. So it's Anova. So all of those mergers brought us a lot of platforms because they were all doing the same business. All of those solutions are what we are calling now the heritage applications. And when we created Anova, the plan was to create a new solution created from scratch and following the cloud native approach and best practice. So we've created the platform which we call Unify. It plans to unify all the mother companies solutions, but not porting anything, creating everything from scratch. And yeah. So let's talk a little bit about our tech stack. Or not talk that much, but we are creating all of our solutions are running inside Kubernetes clusters. And we are using service mesh Istio and doing GitOps deployment with Flux with the help of Hellman Customize. And today I'm going to focus more on Flagger, which is the tool from Weaveworks that allow us to do progressive delivery. Our observability stack is also very interesting. We are not using the elk, for instance, that most of the companies are using. We started using Loki and Tempo from Grafana, which allow us to store logs in a way less expensive way. We are using tools for policy enforcement and a bunch more. We can talk about them a little bit later. So what were the main concerns when we started to create these cloud native platforms from the beginning? We needed a platform who would be resilient and with redundancy, which would allow us to scale the platform depending how our business is growing. We needed, for several reasons, having clusters in multi-geographies, GDPR compliance. We want to keep some customers' data in one continent and others in another. We also have in those geographies multi-region, especially for redundancy and for geo-replication of our data, and multi-environment and multi-tenant, and always security from design since the beginning. So let's talk a little bit about these points. Why resilience and redundancy? Because bad things happen. So we need our cluster to auto-heal and to have our operations team always being alert when anything is wrong. If it's not possible to solve it automatically, at least our people that would be on call to solve. And also redundancy, we are doing geo-replication of our data stores. Scalability, as I said, we need to grow automatically. We put in place Kubernetes autoscale, so even the cluster autoscales according to the needs. All our workloads also autoscale, depending of multiple metrics, depends of the kind of the application. If it's a REST API, would scale in the number of requests, or if it's a Kafka consumer, we will scale up depending on if you are getting consumer lag or not. So multi-geography, we have clusters on North America and on Europe right now. We're going to have also on China in the near future. So as I said, multi-geography is basically because we want to keep data segregated by the way that our customers want. If our customers are American, probably they want their data to remain in the United States. If they are European, they want their data to remain on Europe. Multi-region, as I said, mostly for redundancy and geo-replication of our data in case of disaster. We have an array of environments, production, staging, and sandbox for basically experiments. All of these environments have the same number of clusters that in all environments to be as much close to production as possible. And related to security, we are using global firewall. All our clusters are using private networks. Our managed service are using private endpoints, and we have policy enforcement in place. We are using open policy agent and also Kyverno, and manage identities to keep us from sharing connection strings and so on. We are using pod identity to identify our workloads against our Active Directory. And multi-tenant, what does that mean? So, we have what we call tenant. You can understand it like mostly a team or a project. It's something that has ownership among workloads, or managed service. So we have a new tenant. It's the platform team, let's say, which keeps the main components of the Kubernetes clusters and the managed service. And all of these tenants have teams with people associated to those. In each tenant, we might have a bunch of Kubernetes namespaces, and each team has access to a set or multiple namespace. Let's call it the platform team, and then each team, this tenant A could be a project or a team, doesn't matter. Every tenant is going to have access and full ownership to their namespace. So, and how these tenants, operations and the other tenants, do they deploy their applications? We are using GitOps. I'm pretty sure most of you are already familiar. You're probably also doing yourselves with FluxCD or with Argo CD. There's a bunch of tools. There's a bunch of new tools. So what is GitOps? GitOps is a way, or is how we describe the workloads that we wanted to be deployed on a Kubernetes cluster. So for that, we declaratively specify those workloads through YAML, and then we use a tool that gets that desired state that we specified and do its best to realize our desire, let's say. So we are using Flux for that. We start using Flux V1, and now we are using Flux V2, which it's not sure if you are familiar with Flux, but the first version. I guess there's a question, not sure, and then raise it. Does anyone wants to? Oh no, sorry. There's a few of hands raised. Ricardo, do you want me to answer or continue?
No worries, no, just continue.
Okay, so what Flux does has a bunch of controllers, each one with its own responsibility. Now on V2, on V1, there was one controller that would do everything. There's the source controller, which is the controller that gets or communicates with the GitOps Git repos. So it's the one that knows about sources. Those sources can be Git repositories, but also can be Helm repositories or Helm shards. Okay, and then it's the customized controller, which understands about customizations, because Flux use customize to render the Kubernetes manifests and apply them in the cluster. Some of those manifests can be Helm releases. If we try to, or if we create a resource Helm release, the Helm controller is going to handle and install it with Helm, which is a very common way to install applications on Kubernetes. So everything of this is done by Flux. We just need to specify the desired state with YAML files in a Git repository. In our case, we are using Azure DevOps. So we are not using any of those. So we have a bunch of Git repositories. We can have as many as we want. In our structure, we created, let's call it the main GitOps repository, where we define which clusters do we have in which regions and which environments. I explain later the repository, all of this, but all the observability stack, the service mesh, all of that deployment are going to be described in GitOps main. Each tenant, as I said, also has total ownership of their namespaces, so we provide them also a GitOps repository for each of those tenants, where they have full ownership and they can deploy their workloads or yeah, as they want, completely ownership. So, as you probably saw, there's a lot of environments, and the things that we are going to deploy on those environments and on those regions are mostly the same. But there's a few differences, like URLs or even the number of replicas. We might want in staging to have less replicas than in production. So there's a few differences between its deployment. So we don't want to copy paste all of those YAML files and maintain all of them with just a small set of difference. So for that, we're using Elm releases and customize. This Elm, it's a templating tool, so we just, you probably are aware of it, but yeah, it's a way to install a bunch of Kubernetes resources through templates, which are rendered depending on the default or in the values that we passed when we are doing an Elm install. So, and with customize allow us to have the concept of overlays, where we define the base, or let's say the common YAML for its workload, and then we are able to create patches or overlays to apply on that base, and then we're going to get the common base more those little difference that we want on each environment and region. So I can show you the demo repos. You can find them on my GitHub, just to have a quick overview. Are you seeing my ID? Okay. So there's only an example. Flux, when we install Flux in a Kubernetes cluster, we just need to point it to somewhere. So if you have a cluster on staging North Europe, we point the Flux source controller and to a specific folder. And in this case, we have a bunch of customizations. Let's call it, this is where we want the customized controller to do a customized build against some manifests. So we are saying here, we are telling customized controller, please do your thing on this folder and do your thing on this folder, tenant, staging, North Europe. What it's going to do is use customize, which is expecting to have a customization.yaml file here. So, and one pretty nice thing about Flux too is that allow us to have dependencies on these customizations. I might want one customization to start only after another one finish successfully. An example would be this, where we are installing Kubernetes to enforce our security policies, and we want the policies to be run only after, well, the tool that is going to perform that conformance successfully ends. So we have everything that we want to deploy in our cluster on our operations or platform namespace, like the Istio service mesh, our observability stack is defined here on release, operation releases. We have a bunch of things, all the tech stack that I've told you at the beginning, Loki, we want Prometheus, Grafana, etc. And all of these are using customize, which allow us to specify the common things for every environment. And then we have the specific little things that we just want to change for this particular environment. So we have this huge GitOps repository to define our operations tools, and also, and very importantly, our tenants. Which tenants do we have? What permissions do they have? They have full access to their namespace, but probably we also want them to have read-only or port-forward access to another namespace. We define everything about tenants here, and which Git repos are they going to use, because we need to create the customization, because customization needs to go to their Git repos as well. So in this case, we have two tenants in this example that we can find on GitHub. One it's called data, and another tenant it's called core. And then let's see the example from data. Always the same. Customize is going to look to its region and environment specific folder. So we are always talking here about staging North Europe, the example that I'm going to show you. So customize just looks for the customization YAML, and then gets all the manifests, in this case from this folder, because where is the common manifests, and then applies the patch or the specific things for a particular application, like the URL, let's say. Right here, we have an Helm release, a huge manifest, everything that we want for this critical application. But on staging North Europe, we might want something different, like for instance, the image policy or these hosts, because this host is going to be different in production. It's going to be called production UN, for instance. So those are the repos that we are going to use in our demo. So I've shown you. So, and how are you doing continuous delivery? Well, we are using also Flux for that purpose. In particular, a new different set of controllers, which are called, I think I have it here, yeah, which it's the image reflector controller and the image automation controller. All of our applications, the applications that I guess you should probably ban some of these people here.
Yeah, they're already muted. Yeah, don't worry.
Okay. Thank you. So What the purpose of these controllers? Image reflector controller, or as I was trying to explain, sorry, I got distracted. We are in our continuous integration pipelines. We build our applications as usual, and at the end of that of those runs, we usually build a Docker image and push it to a container registry somewhere. So Flux has the concept of image automation, which having two controllers, the image reflector, which is constantly, from time to time, trying to find new image tags of the workloads that we set it to search. And when it finds a new tag that matches the image policy that we've defined, all of these are Kubernetes custom resources from Flux. Yeah, I have it here. And every time it matches, the image automation controller performs or makes a commit in our own GitOps repository with the new tag that matches the image policy. So with that, we have continuous delivery. For that, we create all of these resources, like image repository is where we define where is the image repository. It might be Docker something. The image policy defines what we want to automatically update, because we might not want just to update every single new image. We might want just to automatically update when we have a major version or a minor, or we might just want to update automatic only where we're talking about patches. Of course, there's the Git repository, because it needs to do that commit somewhere, and the image update automation is a resource where we kind of connect the dots and specify which repository do we want it to commit on, and like the commit message and so on. I can show you also. So are you talking about continuous delivery, but we were talking, or this talk is about progressive delivery. So why would we want it to slow down this continuous delivery? Because again, bad things happen as well. So as good as our integration tests are, we might or we will always introduce some regressions or errors. Even the integration tests, we might have them, but probably are using dependencies with other versions. We really can't be sure that if the integration tests are running successfully, they're going to be fine when we deploy them in production. Or for instance, everything goes well with the integration test, but the latency suddenly increased a lot, so it's going to break our SLO for that particular workload. So we want to do something about it to make it more secure and safe to deploy to production. Yeah. So, and for that, we are using Flagger from Weaveworks as Flux. And Flagger allows us to make Canary deployments or have a lot of deployment strategies. We could do A/B testing and blue and green deployments. Right now, we are only using Canary deployments, which I think is the most important deployment strategy from Flagger. And well, that's a lot of benefits. In short, a Canary, we try to monitor, or when we have a new version of an application, we start progressively sending traffic to that new image and keep monitoring all the metrics to see if anything that we don't want to happen, and we can just cancel the Canary, and the user mostly don't notice anything. So here is a little diagram about how Flagger does that. Here is generic. We are using integrated with Istio. But basically, yes, the users are sending requests through the ingress, and we are going to send progressively some of that traffic to the Canary and to the primary as well, but we keep monitoring the metrics on the Canary, and if anything goes wrong, we cancel and keep the old version. So what is a Canary deployment? A CRD from Flagger, or custom resource from Flagger, where we can define a bunch of things like how and what do you want to analyze when the Canary is running. We might want to, for instance, to perform some load testing against that Canary, and we can depend on the real traffic because it might not be none. So we can simulate traffic and use tools like even K6, not sure if you know, or Locust to perform basically load testing or to generate traffic, so that we are more that we have metrics to measure and decide if we want to promote the Canary to primary or not. Yeah, so how it works, we have our version that it's running fine in our cluster, and after when the image or when we have a new image tag, we start sending a percentage of that real traffic to the new pods with the new version, and progressively, that's where the name progressive delivery comes from, and monitoring those metrics. If everything is okay after some percentage that we define, we just replace or promote the primaries by the new image door that we have and start sending all the traffic to the new version. And after, terminate the Canary, and the Canary is done. So that Canary analysis, in our case, we are using Istio to, and Istio has a resource called virtual service, which is basically an ingress, which allows us to define the weight of the traffic to multiple service. So it allows us to do this progressive traffic proxying between the Canary service and the primary service. And as I said, we can have webhooks where we can trigger tasks to be performing during the Canary analysis, which can be, hey, it's also a, let's say, like a curl on steroids, where we define the number of requests that we want per second and which request do we want, and it just start performance those requests so that we can have traffic and metrics to analyze and see if the latency keeps good or if you have any 500 error or not. Yeah, and then we have a bunch of dashboards to monitor when the canaries are running, and where we can see here is a red dashboard where we can see the rate or the volume of traffic and the errors and how long they are taking. As I said as well, we can do whatever we want during the Canary, and even we could use K6 load tester to perform a bunch of complex or how do you say, complex requests where we could, let's say, request a JWT token to use on a bunch of other requests to authenticate and all of those things. About observability, yeah, we can then, for instance, when we're using K6, we can also send those metrics to Prometheus and analyze them where those load tests are being run. Yeah, and see the logs and everything. Here we are using Loki and with Tempo integrated, where we see the logs. If there's any trace ID, we can just look at the same window all the traces generated. And so I think I'm ready for the Canary deployment demo. I've been talking alone, not sure if anyone wants to ask something before the demo.
We're here. I think the demo would be a good option now, just to to sink in all that information that you just delivered, just so people see that everything in action, all the bits and pieces.
Okay, so let's play a little bit to the god of demos. So here I have a cluster, the same cluster there, or the same deployments that I've shown you on these Git repos that you can find on GitHub. Oh, what happened? Okay, no, sorry. Okay, so let's start. Here I'm going to show you the pods that are running on a data tenant or on data namespace. So I have here a bunch of pods running on this namespace. Let's see. Okay, I have that critical application that I've shown you and a bunch more, but let's focus on this one. This one as a canary because Flagger replaces the name of the application with primary for the tested workloads, and then without primary would be if a canary was running, which is not. So we can just check the state of the canaries right here. Get canary. I could use namespace, but I wouldn't need. So on data namespace, I have only one canary, which is called critical. And then, okay, here, maybe here, let me split this. Here, I'm going to perform requests to that application. And I'm doing a bunch, let's move this faster, like 1 second is hitting this application. Let's see what the logs of this application are. Yeah, here I'm seeing the logs of that application is receiving requests and outputting the endpoint. So I just put it outside to know that these requests are coming from outside, from the internet. And I can show you here also the Elm releases that we have. Then we can look at the Git repo. So I have here, everything looks fine. So let's build a new application. I have here on another, actually, okay, I have here the Docker file that made this critical application. Let's edit the code, which is very complex. And let's say we have a new image and let's deploy a measure. A measure version. Let me just build this Docker image and one. Okay. I'm building, and then I'm going to push this to my Docker hub. And when I do that, I can show you, oh, not FaceTime. Let me show you here. There's a bunch of pods running on Flux, just to show you. So when I push this new image to my Docker hub, this image reflector is going to find that I have a new image tag. So it's going to try to commit it on my GitOps repository. But let's do. So there's already there a new image. So I'm expecting that on my GitOps tenant, where I specify the image tag, sometime this will change. Okay, it's going to take a time because there's cycles to reconcile. I can just make it faster. I can help Flux with Flux reconcile just to find if there's any new tag. Okay, 2 tags. I wouldn't need to do this manually. I'm just making things faster. So there's 2 tags already. Then what I'm going to need is the image of update automation must run, which probably I wouldn't need already. Let me just do a git pull. Okay, it already updated. You can see here, Flux update me this automatically. So it's going to start, it's going to deploy that Helm release. And I'm expecting this canary to be triggered. Might take a while. Let me again make things faster, reconcile the source from Git, and reconcile the customization for data. But again, nothing of this is needed, just to make it fast, and then reconcile the Helm release. Then, okay, Flagger needs to detect that it's a new deployment. Okay, it's progressing. Right now, let me put this a little bit bigger. Okay. The requests. I'm still getting the requests from outside. I'm still getting the response from the old version, because right now I'm still sending to the Canary 0% of traffic. So after the initial bootstrap test is going to started to send 10% of the requests to the new pod, which appears here. I have a new pod. This is the Canary. This is the primary. And here you see 10% of the requests are being served by the new image. So it's going to progress. I define to progress until 50%. And after that, it's going to be promoted to primary. At the same time, we can look at the metrics. We have a nice dashboard for the Istio Canary, where we can see side by side the primary or the current version with the new version. We can look at the memory. We can easily see if there's any spike different from the real or the previous version, the duration, if there's any error, and it's going to progress. These cycles of progressing, we can define them as long as we want. We might want to do these tests 1 minute, 5 minutes for each of these percent. If you see here in the containers logs, here we are seeing the logs from the Canary and from the primary. The Canary are receiving a lot of more requests than the other, because that's the thing that I've told you on webhooks. We are making load testing against the Canary pods only, not against the primary, because we don't want to disturb any real users that we might have. So all of these tests, load testing, are performed against only the canaries. Almost there. When it reaches 50, is going to promote this image to primary. Let's see. Almost there. The elevator music would be useful again now. Ricardo.
We definitely
Okay,
need some music, yeah.
Yeah. And I'm not sure how much I set for this progressing cycle. I think it was 30 seconds. Again, always doing a lot of the load testing against the canary still. So I'm having no errors. So I'm expecting the canary to be promoted to primary, and then started a new pod with the new image, I'm pretty sure, and terminating the vault. We can just check if you are like, okay, describe, deploy, I think what's gonna be critical. The primary, okay. Yeah, it's using the new image. So how do you know that I'm not cheating and everything is always promoted? Let's just again change the code, and let me have here. Let's just create a new version, but an error version. Okay, I have here error. Let's create a patch 101, and this one is going to return 500. So that's an error. Let's build the image 101. And then just push it. So now we can wait to everything to be detected, or we can just make it fast. I like to make it fast, so I will reconcile the image repository, so that image reflector control will detect a different new tag. So I reconcile the image update from data to detect that the image policy matched a new tag and perform a commit on our GitOps repository. It was committed and pushed. Let me see. Probably was. I can show you here. Yeah. Okay, here. There's a new commit which changed the image tag. So we're good. Didn't start the canary yet, but I think it's going to start. I've seen a flickering there, so I can reconcile the source, not this one. Okay, it's progressing. And now I'm expecting to see some errors here in the response. This at the beginning 0, but after the first cycle bootstrapping, I'm going to start to get 10% of the responses error. Still 0%. Okay, I have an error here. So probably I'm going to start to seeing here some 500s on these requests. I'm still It takes a while to get here to Prometheus, but I'm expecting to see some 500 here. I don't think I need that. Okay, I have here a 500. So I'm starting to receiving errors in the metrics. So the analysis, I'm hoping, will fail. We define the threshold, the errors that we accept to be promoted or not. So we are processing, we are performing load testing the same as usual, but I don't expect to progressing that much because I'm a lot of errors. Then I have here the Canary pod and the primary pod. I'm expecting if this failed the Canary, this remain untouched and this will be killed. Okay, still getting few requests, only 10%. It's going to perform the analysis after that cycle, so it takes a while. Please fail. Taking a little bit, we can see the logs of the Flagger itself as well. It's going to say what it's doing. Here is stating that it's doing that load testing. Okay, failed. So it's killing the Canary and keeping the primary pod untouched as we wanted. So there was no deployment of the new version. I'm sorry, you have to fix your bugs. So I think that's it, the demo. Okay, we had still a bunch of challenges in our new platform, like unified observability. We have a bunch of Grafana's for each environment and each region, and probably need federation. I don't know. We are still thinking of this challenge and trying to solve them. And actually, we've done recently a cloud native assessment with cloud container solutions, where one of the donors is the writer of this book. Not sure if you are familiar with it. We still have the report to come, but I think we are in a pretty good stage, we were told. And I think we can have a few questions if you want.
Sure. Thank you, Marco. Thank you very much for the presentation, and thank you very much for the demo. So it's always risky to bring a live demo, and it went really smooth and really smooth. So we have a couple of questions in the chat. I'm going to read the questions, and you can just answer, or if you want, you can read them and answer the questions just so for the video, but as you prefer.
I want to see first where is the chat is. Okay, I guess I found it. Oh, sorry. 99 question. Oh no.
No, just look at the bottom. We had a few spammers on the chat. So you have one from Reto that starts with, what does the load testing do in a real world scenario? And then you have a few questions below that one.
Okay, so to Reto, what does the load testing do in a real world scenario? It can do whatever you think is realistic. We defined a test case which can be specific for the application. As the example that I've shown you with case 6, we have defined specific tests for each individual application. So application A has a bunch of test cases done specifically for that application. They are as realistic as our imagination goes. Yeah. How we ensure does not mess? Well, we have to mostly perform get operations. We cannot be doing updates or inserts, right? Yeah, so they are not handling fake data on production because we are not introducing. You might want to introduce, it's up to anyone, but we are not doing that. We are just performing tests with gets.
Yeah, so in theory we could do that, right?
Yeah,
but
we
we're
could
not,
do
yeah,
whatever
but we could
want.
do whatever we want. So it's possible, just to make the point that it is possible and feasible. In your particular case, you're not doing it at this moment.
Okay, not sure if I answer, but with FluxCD, you can automate. Oh, let me put it here. This one, you can automate the image push and versioning. Yes, that's what I've done, right? It's automatically updated here. When we define an Elm release, let's say this one, this annotation specifies an image policy, and Flux, or in this case, the image automate controller, is going to use this to perform the commit right here automatically. If the image policy, which we define here, we don't define here, but the Elm release will create an image policy based on this input. What I'm doing here is automatically update any image that matches, or where the samware matches everything. So I'm automatically updating everything, no matter if you are talking about a major, a minor, or a patch. I could just fix it here for production. For instance, I just want this major version, and then the rest is automated. But when I want to upgrade to measure free, I need to create a pull request on this repo, and someone needs to approve it. I cannot do this automatically. But this is a demo. I just want to update everything. Not sure if I answer again. You help me, Ricardo. I'm not sure if I answer or not.
I think so. So let me see if we have something here. So what happens when the deployment fails? Do developers get notified automatically?
Yes, we actually, we can be notified on a bunch of ways. But yeah, I didn't show you, I guess. But we have more here. We have more controllers on Flux, like the notification controller. We can handle notification, but we don't even need it because we have all of these metrics on Prometheus, so we can use these on with Alert Manager and trigger a PagerDuty notification alert, or we have a lot of flexibility. But we could use also the notification controller, which we are not using, by the way, for that. Yeah.
Yeah, sure. So if those metrics are in Prometheus or in or like the failed deployments, you can even like build SLOs for deployments and that kind of stuff. So you want to ensure that an X amount of your deployments are actually successful. More questions.
This one, I think, if the Canary deployment fails, okay. No, it's not. The Git remains the same. In order to fix it, we have a bunch of options. We can just change it manually, but we don't need it because the new version there, it's there. But I understand it's kind of, and as I said at the beginning, what is on the GitOps repo doesn't mean it's deployed in our cluster. It's our desired state. We desire to install this image tag, but Flagger didn't let to be installed, but you have to assume this is our desire, not the reality. We have to check if the reality is what it's on that Git repository, which in this case it's not. Right now we have a different version which is running. Actually, we have the reality. The Elm release, if you see the manifest of the Elm release, is already using the new version, but it only deployed that version in the Canary, which failed, and the primary is using a different version. Yeah, so actually, in our case, we are really the same thing in Git repo and in the cluster. Okay, we need to update the image and also a config. Yeah, but all of these configurations and everything in the image, as I said, we do it in the Elm release. If that Elm release renders a config map, probably you just need to set the value here. But we don't need even to use Elm release. You can put anything here or any Kubernetes resource here. I can show you here a bunch of things that are not Elm releases. So we can create whatever you want here. Okay, not this one, as on operations, manifest, base, Flux, I don't know. Here, we are creating Prometheus rules, we are creating pod monitors, we could create config maps, whatever. We can create everything here. We should put in the base the common things, and then in overlays, in the specific environment and region, the little things that we want to change. Okay. Can avoid the Docker push. Sorry. Yeah, we not sure if I understood, to be honest. We always implicitly must do a Docker push. Even we usually do it in our CI pipelines, right? We build a new application and then it's going to be tagged automatically using any tool to Git version, for instance, to increase the image tag, and then the build pipeline is going to push that image to somewhere, right? So yeah, the Docker image must be pushed to a registry to somewhere so that the deployment can get that Docker image. Okay, I guess I answered all the questions.
Yeah, I think that those are all the questions. I don't know if anyone else has another question.
Push and tag automatically, yes.
Yeah, exactly. That's it. So if no one has any question, I want to take this opportunity to thank Marco for the awesome presentation and the nice demo. I hope you all enjoyed it, and thank you for all of being here, and see you on our next meetup.
Sure, and thank you for inviting me. Anything, please ping me on LinkedIn, on GitHub. I'm always around. Thank you,
Marco. Bye-bye.
Bye-bye.